Alright, let's finish this up. Remember, we're finding the equation for the normal line to the function. Y equals 2 cotangent 2x when x equals negative 2 pi over 3. So we already have x and y. Now I need m. I get m by taking the derivative of this and then taking the opposite reciprocal, because I don't want the tangent line, I want the normal line. So let's take the derivative. For the derivative, we have to use the derivative of cotangent, which is negative. Well, the way I remember it is the derivative of tangent is secant squared. So the derivative of cotangent is negative cosecant squared. Is that right? And I'm using the chain rule. So the derivative of the outside with the inside the same. Remember, it has a co sound, so its derivative is negative. So we have, well, that 2 on the outside can stay, but it'll turn negative. Derivative of cotangent would be cosecant squared, except for negative, CSC squared, with the inside the same, times the derivative of the inside, so times just regular 2. And what do we have? We have y prime equals negative 4 cosecant squared to x. And then I'm not going to record it, but I need to figure out the slope when x equals negative 2 pi over 3. So I'll plug in negative 2 pi over 3. So my m value, the m that I want, is going to be negative 4 times cosecant squared of negative 4 pi over 3, right? If I just plug that in, it becomes negative 4 pi over 3. And cosecant, well, cosecant, that's just, well, I mean, I'll show you. 1 over, cosecant is 1 over sine, so this is actually, m is negative 4 times 1 over sine of negative 4 pi over 3, and then I'm putting the squared on the outside. This cosecant squared. And we already did sine of negative 4 pi over 3. That was root 3 over 2, but I'm squaring it. Ooh. So m is negative 4 times, it's root 3 over 2. No, 1 over root 3 over 2. And I'm squaring it. So that means 1 squared is 1, and this squared would be just negative 4, 1 over the 3, just changes to a regular 3, and that bottom changes to a 4, right? Because if I square this, the radical goes away. If I square this, it becomes a 4. And then flip the fraction over and multiply. So m equals negative 4 times 4 thirds, and that's just negative 16 over 3. Sweet. Now I have all my pieces. Let me go make a check mark on that one. Yeah, now I can write my equation. So I'll do that. Y minus y1. So it'll be y minus y1. Well, y1 is already a negative, so it'll be plus 2 root 3 over 3 equals m. Ooh, wait a minute. That's not the m that I'm looking for, is it? That's the slope of the tangent line. We gotta flip it over, don't we? Yeah. So this is actually for the tangent line. Right? Because I didn't flip it over yet. I found the slope of the tangent by taking the derivative and plugging in negative 2 pi over 3. Now I have to flip it over. So my actual m value, so that's wrong. My actual m value is m equals positive, right? Opposite reciprocal, 3 over 16. There we go. So m is 3 over 16. Glad I caught that. Okay. Minus, or x, times x minus x1. x1 was negative 2 pi over 3, so that'll be plus 2 pi over 3. There we go. We're done now. Goodbye.